Well, good afternoon, everyone. On behalf of the University of Washington College of Forest Resources, it's my pleasure to welcome all of you to our 17th Denman Forest Reissue series entitled Ecosystem Restoration. We all look forward today to an exciting and informative program as we investigate a series of issues surrounding the restoration of our land and water resources to place them in a more sustainable condition for future generations. This subject is in keeping with the purpose of the Denman Forest Reissue series, which is to provide information and discussion on timely forestry and natural resource issues facing our region. As with all the activities associated with an academic setting, our ultimate goal is to inform and educate our students, faculty, and staff, as well as resource professionals, citizen groups, landowners, and the general public. These programs are made possible through the generous support provided by the Denman Endowment for Student Excellence in Forest Resources, and they support the college's vision of being a world-class and internationally recognized source of knowledge relevant to environmental and natural resource issues. Before I go into my sustainability introduction, I want to acknowledge the support of two people. Ellen Matheny, who's at our University of Washington Olympic Natural Resources Center in Forks, Washington, handled all of the logistics for today's session, and Bob Edmonds, our Associate Dean for Research at the college, who handled the development of the program. Sustainability is defined in our college as the study that investigates the functionality and the sustainability of complex natural resource and environmental systems in both managed and natural environments using an interdisciplinary approach across multiple spatial and temporal scales that include our urban, suburban, and wildland landscapes. And in our college, we focus on programs that address sustainable forestry, sustainable urban ecosystems, and sustainable forest enterprises. Sustainability serves as the common goal for all of our programs and includes all resources such as timber, horticultural plants, water, wildlife, or insects, for example, considers the needs of future generations as well as those of the present, and strives for a dynamic equilibrium that balances ecological functions and conditions with social and economic factors. Today, we wish to focus on a variety of issues related to the restoration of our natural resource ecosystems in Washington State and beyond. Presentations will be organized into two sessions. In session one, we will be presented with three talks that will address an overview of the principles of ecosystem restoration. And in session two, we will look at examples of restoration and community involvement. Now, there are many examples of ecosystem restoration. First, restoration is being done on a variety of different types of land: forest land, rangeland, mine land, streams, wetlands, urban areas, and other types of areas. And restoration is being undertaken by public, private, and Native American organizations. For example, the 29 tribes here in Washington State are engaged in a variety of habitat restoration projects, some involved on the Quinault Reservation involving marine resources, some on the Yakima Reservation involving forest land restoration, and there are many other examples. With us today in session one of our program to present an overview of the principles of ecosystem restoration are speakers from the University of Washington College of Forest Resources and from the University of Washington, Bothell. Our topic, again, is ecosystem restoration, and I'm very pleased to introduce our moderator, Ms. Michelle Connor, who is Vice President of Cascade Land Conservancy here in Seattle, and I'm very proud to say an honored alumnus or alumnae of our college. And so, Michelle, I'd like to turn the program over to you to introduce our first panel of speakers.
Our first speaker today is Kern Ewing. who I had the pleasure of studying with when I was here at the college. Kern is professor of wetland and restoration ecology in the College of Forest Resources at the University of Washington. Kern received his Bachelor of Science in Civil Engineering and a Master of Arts in Sociology from Texas Tech University. He worked as an engineer and a planner before coming to the University of Washington, where he completed both his Master of Science and his doctoral work in plant ecology in the botany department. He joined the faculty of the College of Forest Resources in 1982 at the Center for Urban Horticulture and started teaching restoration courses in 1992. He started the UW Restoration Ecology Network in 1998 with Warren Gould from UW-Bothell, and for which they received the John Reiger Award from the Society for Ecological Restoration in 2004. His current research focus is on site conditioning to improve restoration success, which involves using mulch, shading, fire, mounding, flooding and draining, and other techniques. The title of Kern's presentation is an overview of ecosystem restoration.
Thanks, Michelle. I'm going to talk to you about restoration today, so it would be helpful if I gave you some of my definitions of restoration. Restoration to me does not necessarily mean that you have to restore to a historical state, because that's something that may not be possible to do. And I also think that restoration can include creation of ecosystems that haven't existed at a place before. There's a third area that's sometimes called ecological engineering that uses a lot of the techniques that restoration ecologists have. But the Society for Ecological Restoration has a definition for restoration ecology, and in this definition, the reestablishment of processes that are found in ecosystems are emphasized. Since I work in a horticulture program, I look at it with somewhat different eyes, and to me, restoration involves the introduction of plant species into a site that's either prepared or not prepared, and then the plants do the work. So plants that are introduced into a system will begin processes that then modify the system. There are a number of elements that are required for restoration to work in the environment in which we live. One set of elements comes from horticulture and agriculture. We've been doing farming for millennia, and it's something that we know how to do fairly well. So the application of the skills of farmers and horticulturalists are pretty important in making restoration projects work. For instance, on a lot of the low-budget restoration projects that we do in our classes, we'll use bare root species. Bare roots are really neat forms of vegetation because they don't cost very much. Students can't damage them very easily. And you can call up someone at the bare root place and they'll mail them to you. So having this kind of access to technology is important to us. Ecology is important in restoration because in any restoration project, we set the project off and we hope that it will go along a trajectory that will reach a goal that we want it to reach. We want to see processes reintroduced onto the landscape. And processes can include things like fire or flooding or grazing. But ecology and the knowledge of ecology kind of gives us an ability to predict what's going to happen to an ecosystem. Regulation has done a lot to allow us to do restoration ecology. The Clean Water Act showed up in around 1970, and it went through a lot of modifications. without the Clean Water Act, we probably would not have started doing wetland restoration as widely and as extensively as we have. We have moved from wetland restoration to terrestrial restoration. There are many statutes and regulations which require us to do restoration. The Clean Water Act was one, the Endangered Species Act, and there are a lot of local statutes and regulations. Community action provides us with political backing to do restoration. Not all restoration projects have a lot of funding, but a lot of restoration projects have a lot of support. In our classes, we teach students to go out and make contacts in communities. People want to see restoration done, and when you don't have much of a budget, having a volunteer corps or a body of people that want restoration to happen is one of the best ways to get it to happen. Finally, there are a number of people who feel that we all live in cities now. I think the number is over 80% of the population is urbanized. And some authors feel that we've lost the link to the land that we once had when everyone was a farmer. There are several authors, including William Jordan III, who is a restoration ecologist, but is a philosopher also, and of course Aldo Leopold, who bemoan the fact that we've lost that link to the land. We don't have a feel for the landscape, so we don't know when it's doing poorly. They feel that restoration is a way to reconnect with the land. And a lot of people come and do volunteer restoration projects because they want to reconnect with the land. They want to feel better. It's exercise, it's outdoors, and there's a certain spirituality involved with doing restoration. Now, as a scientist, I like to think that there is some theoretical basis for doing restoration. And so I've come up with this plan, or with this diagram, which is essentially taken from landscape ecology, which is an area of ecology. And what this diagram says is that as you go from a natural neighborhood, and in landscape ecology it's called the matrix, as you go from a natural neighborhood to a modified neighborhood, restoration is going to become more and more difficult to do as the landscape becomes less likely to restore itself. So whether the modification is as the result of urbanization or if it's the result of agriculturalization, if the neighborhood, the surrounding matrix is unlike what the goal of your restoration is, it's going to take a lot of effort to do your restoration project. And so as the likelihood that a system will restore itself decreases, the amount of subsidy that will be required by us to be put into a restoration project will increase. Now, this is from an old tinted postcard of the whole rainforest. And this is sort of an example of the difference between a natural landscape matrix surrounding a restoration site and a disturbed site. So if you went to the whole rainforest and you cleared a quarter-acre patch of land, chances are that restoration of that quarter-acre patch would proceed somewhat on its own because of lack of weed seeds and propagules, and an abundance of native seeds and propagules, and the right stuff in the soil. However, if you went into an urban environment and had to do a restoration project with this kind of a neighborhood, chances are that your project would require an awful lot of subsidy. This area is actually in Seattle. It's across I-5 from Northgate Shopping Center, and it's near the North Seattle Community College. I don't know if this area was ever disturbed, but even without disturbance, you can see that non-native species are creeping into it, because that yellow stuff there is Scotch broom, and there's blackberry down here. So this is a kind of a site that's going to require a substantial amount of energy and effort to restore. The Millennium Ecosystem Assessment came out a few years ago, and it looked at ecosystem functions as the purpose of restoration ecology. And I like the way that they break up their system of functions. In extremely disturbed landscapes, supporting functions need to be reestablished and restored. And these are things like nutrient cycling, soil formation, primary production. Once those are established, you have a system that functions better, which can then proceed to do provisioning and regulating. And these are both things that provide services for us as a society and that we value in natural systems. And so in provisioning, we don't get a whole lot of food from the forest anymore, but we certainly get fresh water and habitat, and regulation of climate and food and degradation of disease organisms and water purification are things that are important to us. Succession is an ecological theory that is the linchpin for restoration. Succession is an idea that, according to Clements and others, says that succession is the result of a directional change in plants and plant communities at a site. Plant succession is autogenic. It's driven from within. It's driven by the plants that are at a site. It was noticed subsequently by a number of ecologists that there are other things that deflect the course of succession. And there's a long-winded term for this theory. It's the non-equilibrium response to disturbance theory. But it was hypothesized by Pickett and others. And this theory says that the species that occur at a site and the shape that succession will take are the result of three important things. And one of them is site availability, another is species availability, and a third is species performance. Well, that happens to be a good thing for those of us that want to do restoration, because we as humans or as restorers can have an impact on these three things. Site availability is fairly easy to modify or control. In many ecosystems, in ecosystems such as savannas or woodlands, in which there are woody species and herbaceous species, woody species can dominate if there's not something controlling them, like fire. So as restorationists, we can go in with a tractor, or we can go in with any number of different implements or methodologies and remove the woody species, providing a habitat for herbaceous species, grasses. We can have an impact on species availability, that's the second of the three parts in the non-equilibrium theory, by simply planting seeds. This is a rangeland drill. Both of these are rangeland drills. Or we can plant container plants, or we can plant live stakes. And we can modify the availability of plants at a site. The third thing that we can do is we can modify species performance. This picture was actually taken right outside this building, down by the water, at a place that was dominated by reed canary grass. Reed canary grass is a very bad invasive species. What we were able to do with the reed canary grass was mow it down, mulch it, put live willow stakes into it, wait several years while the willow stakes grew up and created shade, and then plant western red cedar into that environment. The original environment was not at all conducive to the growth of western red cedar, but the subsequent environment was great. So we have little western red cedar, which is now above my head. That's about 3 or 4 years old. That's doing well because we modified the site so that the species performance would be improved. Now, this is the last picture slide that I'm going to show you. And it's the Union Bay Natural Area out just west of us. And the reason that I want to show you this slide is to emphasize that restoration projects do not just appear full-blown. This is a very good and well-maintained site, and it doesn't look much like a natural community. The trees were mostly planted 4 years ago in an attempt to get shade. And understory plants were planted just this winter. Everything is doing pretty well. So what this tells us is that restoration projects should not be held to the same standard as landscaping. It takes them a while to get moving. Another thing an important message is that restoration's not instantaneous. Any restoration project that is done will not immediately redress damages to the environment. So there is a lag time before restoration effectively restores functioning to an environment. So my summary slide, restoration depends on a lot of different things, biology and social science and politics. The neighborhood that you do restoration in is critical. It's important. The thing that we're restoring in restoration is most often services that we would like to see at a site. Succession and the plants at a site are the driver, but we can modify the direction that things go by influencing external forces on the process. And finally, restoration takes time. It's not instantaneous. So, thank you.
Our next speaker is James Fridley. Jim is a professor of engineering and restoration design in the College of Forest Resources at the University of Washington. He received a Bachelor of Science in Engineering from the University of California, Davis, a Master's of Science in Agricultural Engineering from Michigan State University, and a doctoral degree in Mechanical Engineering from the University of Washington. His current research focus is on sustainable management and ecological restoration. The title of his presentation today is Ecosystem Restoration as a Design Problem. Jim?
Thank you, Michelle. And thank you for coming and your interest in restoration and, at least for a few minutes, your interest in restoration design. How people design things is something that's of particular interest to me and has maybe been the thread through all of my education and professional experience. Today I'm going to briefly introduce to you the linkage between restoration and design. And I'll talk a little bit about design in general, a little bit about restoration design, and finally I'll talk to you a little bit about how we help our students learn how to manage restoration projects as design projects in our particular approach here. I find restoration ecology to be just an extremely fascinating ology, and I point that out because this is what provides the basis for making the engineering design decisions that go on in the planning for restoration. Because it's something that we plan for and do, it's also, I think, a very interesting industrious endeavor that we undertake. The notion of the term restoration design I think is worth considering, and is that a meaningful term? Certainly architectural design is, mechanical design, garment design, textile design, and maybe by the end of the presentation here you'll begin to form an opinion yourself about the meaningful nature of restoration design. What makes it maybe a little bit different is design is generally thought of as designing something new, and is restoration in fact something new, or is it recovering something that already exists or existed? I think Kern's comments on that were interesting and insightful. And then the last question I'd like you maybe to consider through the presentation is restoration design unique? So we hear the word design used, and I want to point out that the design as a noun is the design, the set of plans. But we also talked very much about the design as a verb. It's the activity, it's the undertaking, it's the thing we do. Folks who study design, if they've done one thing, they've come up with more definitions than there are authors writing them. I think one that might apply well to restoration design is this one, and the point really is taking an idea and generating the information that's needed to produce or fabricate or install, in the case of restoration design, something that isn't there, that hasn't been there before. And so very briefly, I would just say perhaps design is generating plans to, in some sense, make something that doesn't already exist. I'd like to talk a little bit about process models, because it's the way people who study design and teach design can imagine it and visualize it and talk about it. And I want to point out, though, that process models are simply things that we as people do, as authors and teachers and scientists. They're ways to describe something or to model something. And you've probably seen them in things like process model that would illustrate the hydrologic cycle, or a process model to illustrate a legislative cycle. And the one everyone seems to have seen, because we all do science fair in about the 4th or 5th grade, is the one that shows the scientific method. They're often, but not always, expressed as flow charts. So I think everyone, somewhere along the way, has looked at and talked about and investigated the scientific method. I'm not showing you this to talk about the scientific method, but to show you a process model that you're probably already familiar with. This is a very traditional portrayal of a design process model. And the features here show up in virtually anybody that's writing about design. You look in chapter 1 of any introductory textbook, and you'll see those tasks or activities taking place. I'll just point out briefly that while all of you have probably seen and studied and talked about the scientific method process model, very few of you have probably taken time to think about a design process model, and yet you don't go through more than a few minutes every day without encountering yet something else that's been designed that's influencing your life, probably in a pretty big way. Well, just briefly now, why bother to think about this at all? I just would like to point out that the process model gives us a basis for teaching or talking about or setting up processes for things like planning and tracking and making decisions. So it allows an activity, in this case design, to become something that can be managed. And that's pretty important if we want to start talking about things as projects, and projects that people are spending money on accomplishing. But there's a problem with design process models, and that virtually every author will portray a linear design process model, but then when you read on, you find out that what they want to do is they want to say that in reality, every box is connected to every other box. So the process model on the left is nice to write about. The process model on the right is what people end up doing. Now let's talk a little bit about restoration design. In thinking about restoration, we find that it's purposeful. It is highly constrained. As Kern mentioned, it's based on theory. It turns out it's very hierarchical, and it's finite. You can undertake restoration design, and there's a point at which you're done, and you can go on to the next thing. When we say it's purposeful, we mean that we can identify the goal, the thing we're trying to achieve. And in restoration design, that goal represents some future condition that we want to have. Right? And examples of I've shown might be to reestablish a particular type of ecosystem or to return an ecosystem to conditions that we believed existed prior. Restoration is very constrained, though, in that there are limits on everything we do that can be brought about by nature, and those are the ones we understand as science, but they can be brought about by the folks that commissioned the project, the neighbors, the folks in town, regulators. It's endless. But an example might be as simple as saying you can do whatever you want with this restoration as long as you retain the habitat that already exists for whatever. Restoration's based in theory, and that's important because that allows us to predict the outcomes. We have to have a theory to do that. Ecology, applied ecology, provides that for restoration design. And when we predict the outcomes, we might be predicting outcomes that are the outcomes that we see throughout the execution of the restoration project. They might be outcomes that we see immediately upon completion of the installation. And the outcomes might be things that we believe will happen in the future once we've kind of established the restoration and gone off and left it in the hands of the stewards or managers. But what's important to understand is that what makes this what makes restoration a designable undertaking is that we can use these outcome predictions as the basis for making decisions in the planning. Okay? Restoration design is hierarchical. Right? We always look at the big picture before we look at the details. But the details can help us understand the bigger picture. And this creates moving targets, and this is something our students learn to be frustrated with in all of the restoration design classes. And perhaps it points to the fact that it may be hopelessly iterative. We also know as we work down in the hierarchy, as we go from the big picture to the details, we often find that when we specify things, it just brings in more design requirements and more constraints. Right? And to make sure you understand what I'm meaning about this is if we think about the design of something we all use all the time, like a coffee maker, the design decision perhaps to design it with an insulated carafe would be certainly higher in the hierarchy than the decision about what material and the thickness of the material we'd be using in that carafe. In restoration, the decision to use mulch comes higher in the decision-making design hierarchy than does the decision to use a particular commercial fabric as that mulch. All right, so why bother to think about this? Well, if we can bring structure to design, we can, as designers, better understand and meet the purpose of the design, right? And that lets us better avoid unintended consequences. Most importantly, allows us to begin to document the basis by which we're making design decisions, which brings accountability to the design, to the restoration project. And in the end, it makes design, in this case restoration design, into manageable projects. In order to bring this to our student audiences, we've adopted something that we've developed here at the University of Washington called appreciative design. Appreciative design is a stakeholder-based approach to design. It's based on the idea that, one, design is a social process. Design, again, is something people undertake. And in that social process, the perspectives of the designers change over time. This change is the result of events and ideas. So the designer meets with the client, the student meets with the professor, and that changes their perspective of the design problem they're working on. It can be the result of mutual learning. The design team interacts with the client that's brought the design and learns from the client. But in the process, the client learns from the design team and goes away. And when they come back, they've changed their ideas about what they'd like to see, creating, I guess, moving targets. And perspectives change as the result of as we do restoration, we're concurrently doing science, and we're just learning more about how the world works. Right? The other premise is that as we structure the decision processes that we use in design, we make it possible to have better communication and a better understanding of all the stakeholders involved so that we can gain approval for the design that we'd like to have. So the main elements in appreciative design, as we teach it to the students in our restoration courses, is that they acknowledge up front that there are many stakeholders. The problem owner, the one who commissions the stakeholder, commissions the project, is special. The stakeholders bring stakeholder expectations, and as designers, the students need to learn to translate those stakeholder expectations into the functional requirements for the design and understand how the design is constrained naturally, socially, by the stakeholder wishes, and ultimately specify the design parameters, right? The things that they can say, plant this species in these amounts here, okay? Physical things that can be specified by the designer. It's based on designers constantly working with project statements. So in appreciative design, the designers work to develop clear statements of all of the elements in the design in the words of the various stakeholders, and then they work to translate those into the technical language of the scientist and the restoration ecologist. Right? So this is a process of active listening. Right? The aim is for the designers to be able to, wherever they are in the design process, from big picture down to nitty-gritty detail, to be able to talk about all the objectives and the constraints in solution-neutral terms. In other words, we need to be able to talk about what we want to do on the site at all times without prescribing how we're going to do it. And these can be biological functions, physical functions, all the various human functions. And those are then used to translate into the physical design that will be placed onto the site. So in conclusion, we believe that using a disciplined design approach helps to make restoration design more easily organized for the designers, more transparent for the myriad stakeholders that are interested in the outcome of the design, and more likely to succeed ecologically, financially, and politically because the basis for making the design decisions is clearly seen by the designers and then all the other folks who care about it. In other words, we believe that implementing the disciplined design approach makes design projects more manageable, and manageable projects can be repeated and done as a broad endeavor involving lots of people. So it moves it from the realm of just doing stuff to having something that we can teach and can be formalized and can be repeated by others. Thank you.
The last speaker for this session is Warren Gould. Warren is Associate Professor of Plant Ecology and Environmental Science in Interdisciplinary Arts and Sciences at the University of Washington, Bothell. He's also an Adjunct Associate Professor in the College of Forest Resources and Director of the University of Washington's Restoration Ecology Network. Warren received a Bachelor of Arts in Zoology and a Bachelor of Science in Botany from the University of Washington. He received Masters of Science and a doctoral degree from Utah State University in plant ecology. His research interests include ecosystem restoration, especially Arctic and alpine ecosystems, plant responses to ultraviolet radiation, cryptobiotic crusts, and plant responses to cold environments and grazing. The title of his presentation today is Restoration Education in a Community Context. Warren?
Okay, well, thank you, Michelle. And thanks to all of you for coming out today and providing me an opportunity to talk to you about restoration education. Transformation of degraded ecological systems is, as you've heard, a complex process. And with the pervasiveness of human impacts on the landscape nowadays, successes in ecological restoration are becoming really important for us to understand. Education can provide us with a way of understanding the bases behind these ecological successes or these restoration successes, and a means of propagating that knowledge so that successes will become more frequent as we go on. Well, as our previous speakers have indicated, restoration begins with a thoughtful design process and the application of scientific principles. This requires people who are trained in aspects of design, in aspects of the scientific principles that are important for particular restoration projects. But restoration, as Kern has mentioned, doesn't stop with the initial design and implementation. Ecological systems develop slowly over time, and even though that process is largely self-driven, most projects require some degree of active management before they can actually succeed in the field, some degree of stewardship, which oftentimes involves surrounding stakeholders in the local community. Considering all this, it becomes evident that the education of folks who are involved as restoration experts and people who are involved as community stewards or restoration stewards is very important. And here, what we try to do at the University of Washington is to integrate those modes of education. Rather than having them occur in separate spheres, we try to bring together the education of future restoration experts with the education of restoration stewards. We think that's an effective approach. At the university, we're largely in the business of helping students develop a certain amount of expertise, depth of knowledge in a discipline that they might be studying, be it landscape architecture or history or biology or zoology, what have you. But in order to help students apply that expertise in the context of restoration, we really need to move beyond that strict disciplinary educational model. And to do so, today, what I'd like to have you think about are three principles of ecological restoration that really do affect how we go about helping students translate their knowledge into effective ecological restoration. The first principle is a recognition that ecological restoration is inherently multidisciplinary, and our previous speakers have already laid that out. As you restore an ecological system, many times it involves expertise of individuals with backgrounds in natural sciences or engineering, various aspects of social sciences, legal frameworks, horticultural design, landscape design frameworks, geology, soils, wildlife, habitat, and on and on and on. Ecological systems are complex, and restoring them requires a complex web of experts to do that. Well, what does that mean for education? That means that we need, as educators, to be very conscious in providing to our students the opportunity to understand where their area of expertise fits within this web of multidisciplinary approaches to the design and implementation of restoration, and specifically how they can use their expertise in collaboration with others. Our students, for instance, our ecology students, need to be able to learn how to talk to engineers. They need to be able to understand the constraints that other experts operate under and the possibilities that other fields of study can afford to the design and implementation of a restoration project. So this collaborative teamwork, cross-disciplinary aspect of education is an important thing for us to consider in educating students interested in restoration. Secondly, we have to recognize that restoration challenges are specific to the context that they're in. Almost all restoration sites differ to some degree. Certainly there are differences in the goals and objectives of many restoration projects, and that means that solutions that students might develop in any one specific area are not inherently always transferable to another site or another time. And thus, what does that mean for education? It means that we have to be very intentional about grounding students in the development of solutions from underlying scientific principles, the kind of principles that Kern outlined in his talk that allow students to reach back in a new context and develop appropriate solutions for a new site. Okay, and then thirdly, there's a principle that recognizes the importance of stewardship for the long-term success of a restoration project. Our students need to have the opportunities to participate in stewardship building and community engagement in order to really get a handle on how challenging those societal aspects of restoration can be, and develop an appreciation for how important they are for the long-term success of a restoration project. Well, in recognizing these needs at the University of Washington in the late 1990s, we initiated what we call the UW Restoration Ecology Network, and the College of Forest Resources was a key player in the development of that. And this network is really a collection of faculty and students from across the three-campus UW system and across different departments, a collection of people who are all interested in ecological restoration. Well, for students, they come to the UW Restoration Ecology Network with a grounding in the fundamentals of their own discipline that they're studying. And they're immediately placed into an introductory course in restoration ecology. Kern teaches it here on the Seattle campus, where they're exposed to philosophies, philosophical considerations of restoration, and some of the design principles and the scientific principles that we need to grapple with regard to restoration. Some of these students go on to take advanced courses in restoration here, and most of them finish off their restoration education with a hands-on, pragmatic sort of senior capstone. We call it our restoration ecology capstone experience in the end. This restoration ecology capstone is an opportunity for students to take their expertise and apply it to a real restoration project with a community partner in a teamwork sort of collaborative setting. And the spirit behind this is really grounded in the traditional Chinese proverb that says, that can be paraphrased as, tell me and I will forget, show me and I may remember, involve me and I will understand. And I should add that this, the first line is not a license for all of you guys to forget what we're telling you today. So don't take it too literally. But we do involve students throughout the Puget Sound region, all the way from the Nisqually River on up through the Seattle-Tacoma metropolitan area onto Whidbey Island in restoration projects with community partners. Our community partners are highly varied. We work with a lot of local government agencies. We work with schools from the K-8 level all the way up to community colleges. We work with nonprofit organizations and community groups, utility companies, private landowners, and tribal governments have been involved in a number of our projects. Our projects start with the community partners coming to us with a problem. They recognize a problem that they have, an ecological problem, and they bring to us what we call a document we call a request for proposal. It's really a document that lays out, this is my site, this is our place, these are the problems that we see And these are the solutions that we think might be appropriate. That's what they bring to us. And the Restoration Ecology Network responds to that in the autumn, at the beginning of our academic year, by formulating student teams to tackle these projects. To the degree that's feasible, we assemble teams that represent multidisciplinary teams, people with different academic backgrounds, different life experiences, different job training, and so on. It's not always possible to get the sort of mix that we'd like, but we try to do that. And these teams set off on an 8-month-long process of working with their community partner, or what I'll call the client sometimes, in ecological restoration. They take the request for proposal, the client's knowledge of the site, and they undergo a process of fields ecological analysis and produce a proposal for the community partner outlining the general goals and objectives that they think they can achieve on this site. That proposal undergoes layers of review by instructors, by peers, by the community partner, and there's a negotiation phase until all parties who are involved are satisfied with the direction and formally accept the proposal. That's a launching pad for the development of a very detailed work plan in which students actually do the design, convey the solutions to the problems, and ground them very transparently in the scientific principles and bodies of knowledge that are necessary for the development of those solutions. The implementation of the project goes through a number of phases, as many of you are probably aware of in participating in restoration. There are site preparation elements, there is site modification, the installation of habitat elements, plants, habitat structures, and there's stewardship building that goes on throughout this entire process of engaging the community in this. The projects are completed with the development of a final report that details quantitatively, oftentimes, the conditions of the project when the student team leaves the site. The student team develops a stewardship manual, an actual guidebook for the community partner on how to monitor their site, how to use that monitoring information in maintaining the site, so that site has a life beyond when our students graduate and go off to wherever they go off to. And in the very end, and actually this is coming up very soon for us this year, our students go through a synthesis process and critical reflection and a final celebration of what they've accomplished with their community partners. Well, this whole process of the Restoration Ecology Capstone, every year it gets better. It's a learning experience for us as well as the students. And we think it really does begin to address some of these key principles that I've laid out, in that it affords the students an opportunity for hands-on application of their knowledge in a teamwork setting, in a collaborative setting. And it pushes our students to design and implement solutions that are very specific for their site, but yet grounded explicitly, transparently in the science and the knowledge bases that these solutions arise from. And then finally, we do believe that the students' engagement with the community, their continued engagement with the community, fosters their sense of how important stewardship, long-term stewardship, really is for the success of these sites, and the education of stewardship volunteers, other individuals from the community who are going to take care of this site, how important that is in addition to their own education as perhaps future restoration experts. Okay, I'd like to wrap up by coming back to thinking about these three aspects or principles of ecological restoration and what they mean for our approach to educating students. First of all, the idea that restoration is a multidisciplinary endeavor. That means as we educate students in restoration, we need to move beyond simply the good disciplinary grounding that we give them and provide for them the opportunity to work in a collaborative framework and learn the skills that are necessary to collaborate together and actually achieve an objective with folks from different fields of expertise. Secondly, the idea that restoration is oftentimes very context-specific leads us in an educational sense to recognize that students need practice in hands-on restoration in different contexts. But even more important than that, they need practice in connecting very intentionally the solutions that are developed to the underlying scientific principles and bodies of knowledge, so that later on they can dip back into that pool of knowledge and develop solutions for new restoration contexts that they encounter in the future. And then finally, there's the aspect of stewardship, that the importance of stewardship for the long-term success of most restoration projects means that for education, we really have to provide the opportunity for our students to get out there, to engage the community, and to begin to develop this understanding that restoration goes beyond thoughtful design, beyond scientific principles, beyond horticultural principles, and actually encompasses a large part of the success of most projects encompass a societal component, as many of our speakers have pointed out today. And I think by allowing students to participate in community engagement, it fosters their understanding of that aspect. Okay. Thank you very much. That's all I have.
We trust that you enjoyed the program you have just watched. If you have any questions, please send us an email at cfruw@u.washington.edu. Thank you.